All right. So here I'm going to be talking about limits of sums and limits of products. Let's start over here. Limit of a sum. So here we have our piecewise function. F of x is equal to x when x is smaller than or equal to 1. And f of x is equal to x minus 1 when x is greater than 1. And we want to find the limit as x approaches 1 of the sum. Now, initially, your first thought might be that it's equal to the sum of the limits, like this. G of x, x approaches 1. But if you try to do that, so let's try it. So as f of x, for f of x as x approaches 1, well, if it approaches from the left, it equals 1, but if it approaches from the right, it equals 1 minus 1 or 0. So since both one-sided limits don't equal each other, this limit doesn't exist. So what we actually do is we say the limit of a sum is equal to the sum of the limits if you only do the one-sided limits. So what I've written here is this minus sign. This means x is approaching 1 from the left, where x is a little bit less than 1. So now let's try evaluating this. So f of x, where x is a little bit less than 1, it's going to be here. We're going to plug in 1 and get 1. And then we're going to add on what g of x approaches. So x is less than 1. Okay, then we'll plug in 1 to this. We'll get negative 2. Oh, might as well just do that. And so we end up with negative 1. But remember, we have to make sure that each of the one-sided limits of this new sum equal each other. Otherwise, the limit doesn't exist. So now what I'm doing is making sure that the limit as x approaches 1 from the right is also equal to this negative 1. So x approaches 1 from the right. So this plus means x is going to 1 when it's a little bit greater than 1. So x is a little bit greater than 1. So we go over here. That's going to be this part of the function. And we're going to plug in x equals 1. So we're going to get 1 minus 1, which is 0. 0. And then for g of x, we're going to look at where x is greater than 1. So it's this part. And it's just negative 1 all the time. And that sums to negative 1. All right. So now since these two are equal right here, equal, that means that this overall limit is equal to that number. If it hadn't been equal, then it would just not exist. All right. Over here, we got limit of a product. So we're going to solve this the same way. It is just the product of the limits, or excuse me, the product of the one-sided limits. So x approaches 1 from the left, and that's multiplication. X approaches 1 from the left of g of x. And this is going to be equal to, well, let's start with f of x as x approaches 1 from the left. So x is a little bit less than 1. We're going to use this top, that's g of x. We're going to use this top one because x is less than 1, and we're going to plug in 1, and we get 1. So 1, then times g of x when x is less than 1. It's going to be this top part. We're going to plug in 1, we get negative 2. Negative 2. And that's going to multiply to negative 2. Now we're going to do the same thing down here, but with the other one-sided limit. So limit of f of x So x approaches 1 from the right times the limit of g of x as x approaches 1 from the right. It's awful handwriting. Alright, so x is a little bit greater than 1. We're going to use this part, and we're going to plug in 1, we get 0. Then times this other part, which is going to be a little bit greater than 1. We're going to use this, and we get negative 1. This multiplies to 0. So since our two one-sided limits aren't equal, that means that our overall limit doesn't exist. Right, because if the left and the right hand don't equal the same thing, then overall limit can't exist. And there you go. That's how you find limit of a sum and limit of a product. It is just the sum of the limits and the product of the limits, as long as you do the one-sided limits.